When we're drawing Lewis structures, remember the first thing we want to do is count up our valence electrons. So here, carbon has 4. We have 2 oxygens. Each oxygen has 6. So we have a total of 16 electrons. Next, let's draw our structure here. And I use line dot notation, so we're going to do that. We're going to connect ours so that each line uses 2 electrons. So I've used 2, 4, 6, 8, 10, 12, 14, 16. That's not going to work, is it? Nope. So this carbon can say, it's okay, I'll share with you. So then this one still has 8. Everybody wants 8, remember that. So carbon has 2, 4, 6, 8, but this oxygen still only has 6. So probably what most people do, I drew this kind of weird, is share it like that. So you have, the carbon has 2, 4, 6, 8, and then each oxygen has 2 lone pair on it. So here, we kind of draw those where it's a little bit easier to see. There we go. Now, NBr3. N has 5, 3 times 7, so we got 26. Nitrogen, bromine, bromine, bromine. All right. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Good, we used them all. NCl3. Nitrogen has 5. Oh, that's 7. So same thing, 26 electrons. Draw your structure. Again, how you draw or you orient your molecules does not have to look like mine, but hopefully it will. Or look similar. As long as you draw me a valid Lewis structure, it's going to be okay. H2O. Hydrogen has 1. Oxygen has 6. We have a total of 8. Remember, hydrogen can never go in the middle. That wants to be our least electronegative element that's not hydrogen. So do them like that, connect them, and then use your excess arrows. And hydrogen also only wants 2. Hydrogen is a duet, so it only wants 2. All right, CH4. You have 4 hydrogen, each with 1 electron, and then carbon has 4, so you have a total of 8. And then connect them. 2, 4, 6, 8, no extra electrons, done. Okay. Here we have a little more complex molecule, or at least it looks like it might be. So we have 4, 3 times hydrogen, and 7, we've got 14 electrons. All right, remember, hydrogen can't go in the middle, so the formula does not always reflect how the structure should go. Carbon is your least electronegative atom that's not hydrogen. Two, 4, 6, 8, 10, 12, 14. So this is fairly common organic type notation. These H's that occur right after the carbon tell you that these H's go on the carbon. We'll see more of those shortly. CCl4, 4 from carbon, so 28, so it looks like we got 32 electrons to deal with here. Carbon is the least electronegative. Connect them all, that's 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. All right, HCN. H has 1, carbon has 4, nitrogen has 5, so we've got a total of 10 electrons. This time it actually works out where the least electronegative one is in the middle. Sometimes when you have the H coming before the carbon, that means it's still attached to the carbon. And again, at this point, it's going to be okay if 6, 8, 10. All right, well, we've used 10 electrons, but carbon doesn't have 8. If you draw me a valid Lewis structure, it's going to be okay. All right, hydrogen's happy, it has 2. Nitrogen's happy, it has 8, but carbon only has 4. So nitrogen says, it's okay, I'll share. All right, nitrogen still has 8, but carbon only has 6. So nitrogen says, it's okay, I'll share these with you too. There we go. So sometimes you have to make triple bonds. H2S. H has 1, S has 6. So there are a total of 8. Hydrogen cannot go in the middle. And at this point, we're not drawing any sort of rings. Rings are organic, so nobody draw any triangles or rings.